So let's go for the last part of the discussion today and talk about dreaming. First of all, it would be important for us to have a sense about how different parts of the brain would be working during the process like REM sleep. First of all, the patterns of brain activations in slow wave sleep could be quite similar to some of the patterns that we have in kind of being awake, or just kind of the diminished activities that we can have in a slow wave sleep activities. But we have the characteristics pattern that we have during mainly REM sleep is that we have a good level of deactivation in DLPFC, a good level of deactivation in what we call posterior cingulate cortex, and also good deactivation in the part of the brain which is called, this is basically when we have dreams. In primary visual cortex. Obviously, when we are dreaming, we are experiencing or re-experiencing some visual representational maps in the brain. But these visual representational maps are not from primary visual cortex. So we know that we do not need primary visual cortex for having those visual imaginations or visual re-experiences that we can have during dreaming. We just need to have secondary visual cortices and even tertiary visual cortices that they have a good kind of complex visual representational maps, and they can give us good kind of complete multisensory visual representation and visual experiences for us. So we really do not need primary or preliminary visual processing of information, because the information has already been processed for us before. So we do not need primary visual cortex for being able to dream. We just need to have secondary visual cortices. The other thing that is quite interesting is just the lack of activation in posterior cingulate cortex. And that is the reason that sometimes what we are experiencing in dreams could be sort of out-of-body experiences. So sometimes we can just even see ourselves from outside. So we can basically detach ourselves from the dreams that we are making, in terms of even seeing ourselves doing something, but we are pretty much far from something like out-of-body experiences that we might be experiencing, because the posterior cingulate cortex is critical in terms of integrating yourself to the experience that you are making. And then you have DLPFC deactivation. When you have DLPFC deactivation, DLPFC is the site for, let's say, logical thinking and putting things in order and planning things together in order and suppressing some bizarre behaviors. But then the DLPFC is out of line. I mean, you can experience lots of bizarre, out of control types of behaviors that you usually do not have when you have DLPFC on board. So it's something like hallucinatory, even schizophrenic-like hallucinations that you can experience, because this is the way that, I mean, even those who have schizophrenia, most of the time they do not have their DLPFC on board. So that is the reason when we have DLPFC out of board, we might have those bizarre experiences as our dream. So that is, I mean, these patterns of brain activation could explain to some extent how we experience dreams that seems a little bit chaotic sometimes, or non-relevant to the reality that we have been experiencing before. But we still have lots of activations in interesting parts of the brain in terms of the activations that are related to visual imaginary, different sorts of kind of areas that are related to emotional processing. Especially we have amygdala activated in a significant kind of way, so that is the reason that we can have complete emotional experiences that we have dreams. And we can have also kind of reward processing areas in pontine tegmental area, And that is the reason that we can have euphoria or pleasures or something like even orgasms, things related to sexual experiences while we are dreaming. And as I told you, we can have dreams in all these different steps, and the dreams could be different. Most of the time, I mean, dreams could be related to all these steps. And I mean, as I told you, there could be variations in terms of experiences that you can have for dreams in all these different steps. As I told you, I mean, dreams, for example, in this part could be more logical. This part could be more illogical. Here could be kind of bizarre. So we can have different types of dream in different parts of the sleep. Okay, that is sort of a complex figure, but it's not really complex. It just seems complex. And I put it here from a Nature Neuroscience review paper that I really like, so you probably can read that. It's easy to find. It's pretty much old, but it's quite interesting to see that how things have not been changed very much from something like 20 years ago in some aspects of our understanding about sleep and the gaps that we still have with the sleep. But these are the ideas of, okay, that we have all these subcortical and cortical areas involved in what we call the dreaming process and how they play a role. For example, number 4, DLPFC, plays a role in terms of when we have DLPFC out of line, then we have loss of volition, loss of logic, orientation, and working. So these things could be just because of having dorsolateral prefrontal cortex out of this process. And then things related to, as I told you, LGN and LGN regarding the PGO and how these information are important in terms of the sensory processing that we can have for during REM sleep. So there are all these pieces are playing. So it's really hard to say which part of the brain is involved in this process. And I usually kind of, when I receive some questions from students, they was, okay, what could be the function of when we are doing this, what areas involved? It's just really hard to say. Most of the brain is involved in most of the things that the brain is doing. So it is just different level of contribution that different parts of the brain could have. But it's just something like one of the last figures in the class today. Just give you an overview about what we have discussed about. For example, in REM sleep, as I told you, we have amygdala on board. So that is the reason that we have emotional experiences during dreaming, during REM sleep. Amygdala is interacting with medial prefrontal cortex and hippocampus through what we call theta oscillatory rates, oscillatory kind of synchronizations. And that is the mechanism that we use for promoting consolidation of affective information. So that is the mechanism that plays a significant role in consolidating affective information that you have collected. And there are ideas in terms of, for some specific reasons, improving theta wave oscillatory rate between amygdala and hippocampus to improve consolidation, or sometimes just disrupting theta wave oscillations because of that we really don't like those memories to be consolidated. For example, you have fugitives from a war zone, and they are just kind of trying to escape from the war zone, and you are in the middle of the war kind of area, and you like to help these fugitives with something that help them not to record the information that they have seen during the day, during the night. So there might be potential that we can use brain stimulation for those people. And the good thing about this device that we are developing right now with oscillatory stimulation, they could be used in, let's say, middle of sub-Saharan kind of countries in the middle of the war with just a couple of $100. So they could be pretty much easy to be used. So there are ideas for improving or disrupting this theta oscillatory interaction between amygdala and hippocampus because of improving memory or just erasing memories that people have seen during the day. And as I told you, the brain stem through the PGO waves would interact with these systems to just get them activated and bring up some activations. As I told you, there is a kind of role for acetylcholine that is important for recording this information. And it might be interesting for you to know that acetylcholine would be just go down during Alzheimer. And that is one of the reasons that we do not have a good level of consolidation of information in Alzheimer's disease. And that's the reason that some of the kind of the medications that we have for Alzheimer's, things like Exelon, things like that, are basically just improving the level of acetylcholine, and they have a significant role for improving the level of acetylcholine to be able to have the consolidation process here. But as I told you, for non-REM, we have slow wave interactions from prefrontal cortex to hypothalamus. And also we have talked about the slow wave ripples from hippocampus to different cortical areas, and how they play a role for iteration of information and re-representation of information that we have collected during the day, to be able to see how these pieces of information should be organized in under different shelves, then to be recorded in the REM sleep into the shelves. Just to give you a sense about this, how this system is working, let me just give you 2-3 examples of sleep disorders that we might be experiencing, and just wrap up the things that we have discussed about today. One of the things that you might have heard about is called confusional arousal. And this is a specific experience. If you just be awakened at the middle of a slow wave sleep. I'm not sure, have you ever experienced that in terms of taking a nap for the afternoon. Your idea was just taking a nap for something like 15 minutes, and then you ended up having something like a 2 hours afternoon nap. And when somebody is just waking you up, or you are just waking up yourself, you had been in something like a slow wave sleep kind of experience here. And then when you get out of the bed, you can just be confused, and there are sometimes even you can have this confusion for the entire remaining of the day that you have, because of being in that, let's say, slow wave sleep state. And that could give you that confusional arousal after being awake, and that confusional arousal would make things really complex for you to be able to get back to a normal functioning. And so that could be one of the disorders that people can experience when they just get out of the sleep in a kind of non-proper way. And sometimes there are people who are just experiencing that very frequently, in terms of just getting out of the sleep in this state. And as you can imagine, that could be really problematic in terms of experiencing that as something that is not obviously pleasant experience of just getting out of this process. And that might be kind of really kind of a bad experience that people can have. The other thing that might be interesting, basically the last item that I want to tell you about, is what we call sleep paralysis and sleep enactment. And what we mean by sleep paralysis, it means that you get to the REM sleep, you have your atonia in REM sleep, you just wake up from REM sleep, your atonia is not gone yet. So you still have your atonia, you're out of sleep, you just feel that you can just turn your eyes around, but you feel that you are paralyzed. And meanwhile, you are out of something like a really bad experience of a bad dream or negatively balanced dream during your REM sleep, and you feel you are paralyzed as well. So you have your awareness and your consciousness is back, but your motor system is not back. So it seems that somebody forgot to turn on the motor system. So I mean, they have just turned on all the other knobs, but this one has been forgotten. Somebody forgot to just turn on the motor system, and you feel that you are paralyzed, but you are awake. And that's the really bad experience that some people experience. There is a specific term for that in different cultures. For example, in Persian culture, they call it sometimes bakhtak. So people feel that, I mean, they are out of sleep, they are just freezed and they cannot do anything. So, and there are some, let's say, mystical behaviors that, I mean, there are, I mean, some, let's say, out-of-world powers that are controlling you. So you are just out of sleep, but you cannot kind of move your body. So that's a kind of a really bad experience. But that shows how this system is working. And if one part of this system is not working perfectly well in synchrony with other parts, then the problem would be there in terms of how these parts of the system are going to interact with each other. And then there is another kind of problem with what we call enactment, is that you get to the REM sleep, but somebody forget to just turn off the motor system. So you are in REM sleep and you start to just jump around and just kick off whoever is kind of sleeping in the bed with you, and that would be problematic as well. So people would have enactment of whatever they have in their brain during the REM sleep because of not having their motor system out of the system. So both sides could be problematic, and both sides could be REM-related, what we call parasomnias, in terms of the parallel problems associated with sleep. And sometimes they call REM sleep behavior disorder, something like that, RBM, something like, or RBD. That would be, I mean, these are specific sleep disorders. So there could be, when you understand the mechanism of this system in terms of how REM sleep is working, how non-REM sleep is working, you realize how having disorders in any stages of this process could make different problems in terms of sleep challenges, and people experience that. And there are, I mean, these sleep problems are quite frequent overall when we put them all together in a category. So that is the end of this session.